Good morning, students. Welcome back to maths class. The chapter is Principle of Mathematical Induction. Okay, today is last class, Principle of Mathematical Induction. Tomorrow we'll start new chapter. Today another 3-4 problems we'll discuss. Principle of Mathematical Problems. Okay. Next question. Already 26 questions are over. Prove that 10 to the power 2n minus 1 plus 1 is divisible by 11. Is divisible by 11 for all positive integer n. This means natural number. Positive integers are what? Natural numbers. For all n belongs to n. Okay. First, we have to apply P of n with the given statement. 10 to the power 2n minus 1 plus 1 is divisible by 11. Is divisible by 11. Next, step 1, verify the statement P of n is true for n equal to 1. Step 1, for n is equal to 1. For n is equal to 1. That is P of n means 1, 10 to the power 2 into 1 minus 1. 10 to the power 2n minus 1 plus 1. Okay, equal to 10 to the power 2 into 1 to 2 minus 1 is 1 plus 1 equal to 11. 10 to the power 1 is 10 plus 1 equal to 11. Is divisible by 11. Is divisible by 11, which is true. Okay, 11 is divisible by 11, which is true. Okay, therefore P of 1 is true. Therefore P of 1 is true. Next, step 2, let P of n be true for n is equal to m. N is equal to m. P of m 10 to the power 2m minus 1 plus 1 is divisible by 11. That is, we have to take 10 to the power 2m minus 1 plus 1 is equal to 11 lambda. Lambda is an integer. Lambda into 2 is divisible by 11. Okay, 10 to the power 2m minus 1 plus 1. 11 into 2 is divisible by 11. 11 into 3 is divisible by 11. Okay, this is equation 1. Where lambda is an integer. Okay. Next, step 3 mention where lambda is an for some constant. Lambda is an integer. Okay. Let P of n be true for n is equal to m plus 1. Okay. That is P of m plus 1 is 10 to the power 2m 2 of 10 to the power 2 into m plus 1, 2 into n replace m plus 1 minus 1, okay, plus 1 is divisible by 11. Is divisible by 11. Okay, prove this statement. 10 to the power 2 into m plus 1 minus 1 plus 1 is divisible by 11. Now we have to take 10 to the power 2 into m plus 1 minus 1 plus 1 equal to 2 into 10 power 2 into m 2m. Okay, plus 2 into 1 2 minus 1. Okay, plus 1. Okay, equal to 10 to the power 2m minus 1. You have to take 10 to the power 2m minus 1 plus 2 separate plus 1. Instant 2m minus 1 right first, next plus 2. Or 2 minus 1 is 1. 2 minus 1 is 1. After that you are taking 2 minus 1, separate you are taking 2. Minus 1 plus 2 is what? Plus 1. Okay. You are taking 2m using equation 1, 10 to the power 2m minus 1. You are taking 11 lambda minus 1, substituting. Okay, 10 to the power 2m minus 1 plus 2 can be written as 10 to the power 2m minus 1 into 10 square. A power m plus 1 is equal to what? A power m plus n is equal to a power m into a power n. Bases are same than adding powers. Okay, 10 to the power 2m minus 1 into 10 square. Okay, into 10 square plus 1 as it is. Plus 1 as it is. Next, 10 to the power 2m minus 1 can be written as 11 lambda minus 1 from equation 1, using equation 1. Now, 11 lambda plus 1 goes to RHS side minus 1. Okay, into 10 square is 100 plus 1. Okay, using equation 1. Using equation 1. Using equation 1. Okay, next 11 lambda into 100. 11 lambda 11 lambda into 100 minus 1 into 100 minus 100 plus 1 as it is. 11 lambda into 100 minus 1 minus 100 is 99. 1 minus 100 is minus 99. Next, 11 is common. 100 lambda minus 11 minus 9. 11 into 9, 99 is divisible by what? Is divisible by what? Which is divisible by 11, which is multiple of 11. Okay, which is divisible by 11. Okay, therefore 10 to the power 2 into m plus 1 minus 1 plus 1 is divisible by 11. Okay, 10 to the power 2 into m plus 1 minus 1 plus 1 is divisible by 11. Therefore, P of m plus 1 is true. P of m plus 1 is true. Last step as this. Step 4. By the principle of mathematical induction, P of n is true for all n belongs to n. Okay. Next question. Eight. Prove that 3 to the power 2n plus 2 minus a10 minus 9 is divisible by 8 is divisible by 8 for all positive integer. This means for all n belongs to capital N. Okay. Solution. First, let clear P of n be the given statement. Step 1. Verify the statement P of n is true for n equal to 1. Let P of n 3 to the power 2n plus 2 minus a10 minus 9 is divisible by 8. Okay. Next, step 1, for n is equal to 1. Here P of 1 3 to the power 2 into 1 plus 2 minus 8 into 1 minus 9 equal to 3 to the power 2 into 1 2 plus 2 4. 3 to the power 4 minus 8 minus 9. 3 to the power 4 value 81. 81 minus 17. Minus 8 minus 9 minus 17. 81 minus 17 is 64. 81 minus 81 minus 17 and minus 6 is 4. Okay. 64 is divisible by what? 8 is divisible by 8 is divisible by, which is true. 64 is what? Divisible by 8. It's multiple of 8, which is true. Which is true. Therefore, P of 1 is true. Therefore, P of 1 is true. Next, step 2. Let P of n be true for n equal to 1. Let P of n be true for n equal to m. That is P of m 3 to the power 2m plus 2 minus 8m minus 9 is divisible by 8. Okay, this implies 3 to the power 2m plus 2 minus 8m minus 9 equal to 8 lambda. Equal to 8 lambda. Okay, 8 into 2. Lambda is an integer. 8 into 2, 8 into 3 is multiplied by what? 8 is divisible by 8. Okay, where lambda is an integer. Lambda is an integer. Next, step 3, P of n be true for n is equal to m plus 1, for where lambda is an integer. For some integer lambda. Next, step 3, let P of n be true for n equal to m plus 1. Okay, to show that P of m plus 1 is true. To show that P of m plus 1 is true. That is P of m plus 1 3 to the power 2 into m plus 1 plus 2. 2 into n replace m plus 1 plus 2 minus 8 into m plus 1 minus 9 minus 9 8n, okay, is divisible by 11 8. Okay, this we have to prove. Now we have to take 3 to the power 2m, 2 into m plus 1, 2 into m plus 1 plus 2 minus 8 into 8, m plus 1 minus 9 will prove is divisible by 8. 3 to the power 2 into m plus 1 plus 2 minus 8 into m plus 1 minus 9 equal to 3 to the power 2m plus 2 plus 2. Okay, 2 is multiplied. 2 into m, 2 into 1, 2 plus 2 as minus 8m minus 8 minus 9. Minus 8 into m minus 8m minus 8 into 1 minus 8 minus 9 as it. Now 3 to the power 2m plus 2, okay, into 3 square. Observe that equation 1, 3 to the power 2m plus 2 can be written as 8 lambda minus that side plus 8m plus 9. Okay, minus 8m minus 8 minus 9 minus 17. Okay, 3 to the power 2m plus 2 can be written as 8 lambda minus 8m that side plus 8m. Okay, next minus 9 that side plus 9 into 9 3 square is 9 minus 8m minus 17 from equation 1. Okay, this one can be written as 3 to the power 2m plus 2 equal to 8 lambda minus 8m that side plus 8m minus 9 that plus. This is equation. Okay. 3 to the power 2m plus 2 can be written as 8 lambda plus 8m plus 9. Next, 9 is multiplied. 9 into 8, 72 lambda. 9 into 8, 72 m. 9 into 9, 81. Minus 8m minus 70. Understood? Next, 72 lambda as is. Next, 72 m minus 8m. 72 minus 8m. 64. 64 m. 81 minus 70. 64. 72 m minus 8m is 64 m. Next, 81 minus separating lambda terms, m terms, constant terms. Okay, now totally 8 is common in this equation. Next is 9 lambda, 8m plus 8. Is multiple of which is multiple of what? 8. Which is multiple of 8 is divisible by 8. Okay, which is P of m plus 1 is okay. Next question. 28, 29. Prove that n into n plus 1 n plus 2 is a multiple of 3, is a multiple of 3, is a multiple of 3. Is multiple of 3. Okay, same procedure. First you have to apply P of n into n plus 1 n plus 2 is a multiple of 3, is a multiple of 3. Next, step 1, for n is equal to 1. Next, P of 1 into 1 plus 1 1 plus 2. Okay, 1 into 1 plus 1 2, 1 plus 2 3. Okay, 1 plus 1 2. Next, 1 plus 2 3. 1 into 2 into 3 is 6. N into n plus 1 n plus 5. Correction is, this problem is n into n plus 1 n plus 5, n into n plus 1 n plus 5, not 2. Okay, n into n plus 1 n plus 5. This is 5. Okay, next 1 plus 5 6. 1 into 2 into 6 is 12, which is multiple of, which is multiple of, is multiple of 3, which is multiple, which is true. Okay, therefore P of 1 is true. Next, step 2 as is. Step 2, let P of n be true for n equal to m. N equal to m. P of m, n in m into m plus 1 m plus 5. M plus 5 is a multiple of 3, is a multiple of 3. This implies m into m plus 1 m plus 5 is equal to 3 lambda, is equal to 3 lambda. Okay, where lambda is an integer, for some integer lambda. Okay, this one can written as m into m square plus m into 1 m plus 5 equal to 3 lambda. Okay, all are multiplied. M square into m cube. M square into 5 m square. M square is over. M into m square. M into 5 m equal to 3 lambda. M cube plus 6m square plus 5m is equal to 3 lambda. This is equation 1. Okay, m 5m square plus m square is 6m square. Next, step 3, let P of n be true for P of n be true for n is equal to m plus 1. To show that P of m plus 1 is that is P of m plus 1 n into n is m plus 1. Next m plus 1 plus 1. Next m plus 1 plus 5. K is a multiple of 3. Prove this statement. Now m plus 1 plus 1 plus 1 m plus 2 m plus x is multiple of 3. Prove this. Now we have to take LHS m plus 1 into m plus 1 plus 1 m plus 2 m plus 1 plus 5 m plus 6 equal to m plus 1 into m plus 2 first multiply m into m square m into 2 2m 1 into m plus 2 m plus 2. Next m plus 6 m plus 6. Again m square plus 2m plus m 3m plus 2. Okay, m plus 6. Again multiply each one m square into m cube. M square into 6 6m square plus 3m into m 3m square plus 3m into 6 18m 3m into 6 18m. Next 2 into m 2m plus 2 into 6 12 2 into 6 12 each one multiple. Next separating m cube terms square terms. Next m terms and constant terms. 6m square plus 3m square 9m square plus 18m plus 2m 20m plus 12. This equation can be written as m cube plus 6m square plus 5m equal plus 6m square plus 5m plus 6m square plus 5m plus next we will get 6m 9m square can be written as 3 plus 3 square plus 6m square. Okay, now we get 3m square. 6m square plus 3m square is 9m square. Or this one separate m cube plus 9m square or separately 6m square plus 8m plus 2 then you get 20m. Now 3m square. Next 5m. 20m can be written as 5m plus 15m. Then write 15m. Already 5m right. 15m plus 5m 20m plus 12 as it is. Plus 12 as it is. First equation can be written as 3 lambda. M cube plus 6m square plus 5m is equal to what? 3 lambda. 3 lambda plus this one 3 is common 3m square plus 15m plus 12. In this equation 3 is common. Now we get m square plus 5m 3 to 5 15 plus 3 into from equation 1 using this one. Total these two equation 3 is common, then we get lambda plus m square plus 5m plus 4 which is multiple of 3. Okay, or 3 into mu or k where k is equal to what? Lambda plus m square plus 5m plus 4 which is multiple of 3 divisible by 3. Okay, therefore this one, m plus 1 into m plus 1 plus 1, m plus 1 plus 5. This means m plus 1, m plus 2, m plus 5 is multiple of 3. M plus 1, m plus 2, m plus 5, m plus 6. M plus 6 is multiple of 3. Therefore, P of m plus 1 is true. Step 4. By the principle of mathematical induction, P of n is true for all n belongs to n. Okay. Last question. 29, 30, 30, 30. Last question. Prove that prove that 2n plus 7 is less than n plus 3 whole square for all positive integers. For all n belongs to n. For all n belongs to n. First, we have to apply P of n. 2n plus 7 is less than n plus 3 whole square. Okay. Step 1. Step 1. For n is equal to 1. P of 1. 2 into 1 plus 7 less than 1 plus 3 whole square. Okay, this implies 2 plus 7, 9. 2 into 1 to 2 plus 7 is 9. 9 is less than 1 plus 3, 4. 4 square. 4 square. This means 9 is less than 16. 9 is what? Less than 16, which is true. Okay, which is true. Therefore, P of 1 is true. Step 2. Let P of n be true for n is equal to m. N is equal to m. Okay, that is P of m. 2m plus 7 is less than m plus 3 whole square. Equation 1. Okay. Next, step 4, step 3. Step 3. Let P of n be true for n equal to m plus 1. Okay. Next, to show that P of m plus 1 is P of m plus 1 is that is P of m plus 1 2 into m plus 1 plus 7 is less than m plus 1 plus 3 whole square. through this statement. Okay. Now we have to take 2 into m plus 1 plus 7 equal to 2m plus 2. 2m plus 2 plus 7. This equation can be written as 2m plus 7 plus 2. Okay, you have to use equation on 2m plus 1. 2m plus 7 is less than what? Is less than 2m plus 7 is m plus 3 whole square plus 2. From equation 1. From equation 1, 2m plus 7 is what? Less than m plus 3 whole square. After that, we have to mention less than m plus 3 whole square is expanding. M square plus 3 square is 9 plus 2 into m, 2m, 2 into m, 2m, 2m into 3, 6m. Okay, plus 2. Expanding a plus b whole square. M square plus 6m plus 11. This equation can be written as, then you have to prove this condition, m plus 4, m plus 1 plus 3, m plus 4, 2m plus 1 plus, this means 2m plus 9 is less than m plus 4 whole square. Through this statement. Okay, m square plus 8m plus 4. Okay, now we are taking 9. 9 plus 2 is 11. Now we are taking 16 minus 2m. 8m minus 2m, 6m. 8m minus 2m, 6m. Next minus 5. 16 minus 5, 11. 16 minus 5, 11. These first three terms can be written as m plus 4 whole square minus 2m plus 5. Therefore, now 2 into m plus 1 plus 7 is less than m plus 4 whole square. 2 into m plus 1 plus 7 is less than m plus 4 whole square because 2m plus 5 is greater than 0. 2m plus 5 is greater than 0. Okay. Now this one is less than m plus 4 whole square minus will get 2m plus 5 is greater than 0, then we will get m plus 4 is 0. Therefore, P of m plus 1 is 2. By the principle of mathematical induction, P of n is 2 for all n belongs to n. Okay. Over this chapter finished. Principle of mathematical induction. Okay. Very simple. Then we get step 1, step 2, step 3, step 4. Step 1 is 1 mark, step 2 is 2 marks, step 2 is 1 mark, step 3 is 2 marks, step 4 is 1 mark. Total 5 mark question, 5 marks. In this chapter, only one question will get in part D. Okay. I am telling some questions, assignment, all of you send in the group. Okay, answers. First I am telling you some important questions. Must and should all of you send in the group in PDF. Important questions I am telling previous year questions. I'm telling. Assignment. First one, prove by mathematical induction 1 plus 2 plus 3 plus and so on n into n plus 1 divided by for all n belongs to n. Okay. Second one, prove by mathematical induction 1 square plus 2 square plus 3 square and so on n square n into n plus 1 to n plus 1 whole divided by 6 for all n belongs to n. Next, third one, prove by mathematical induction 1 cube plus 2 cube plus 3 cube and so on n cube. Okay, n square into n plus 1 whole square divided by 4 for all n belongs to n. Okay, next fourth question, prove by mathematical induction 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus and so on 1 by n into n plus 1 equal to n divided by n plus 1. Okay, for all n belongs to n. Next question, prove by mathematical induction 1 into 2 into 3 plus 2 into 3 into 4 plus and so on n into n plus 1 n plus 2 equal to n into n plus 1 n plus 2 n plus 3 whole divided by 4. Whole divided by 4. Another two questions I am telling. Prove by mathematical induction 1 plus 3 square and so on 3 to the power n minus 1 equal to 3 to the power n minus 1 divided by 2 for all n belongs to n. Prove by mathematical induction 1 into 2 into 1 by 2 into 5 plus 1 by 5 into 7 5 into 8 plus 1 by 8 into 11 plus and so on 1 divided by 3n minus 1 into 3n plus 2 equal to n divided by 6n plus 4. Okay, for all n belongs to n. All of you solve these questions. Okay, assignment questions. All of you must and should tomorrow send in the group. Okay, in PDF file. All of you. These questions are recorded in this chapter. Okay, we are asking this one by one questions. Okay, today this chapter is finished. Tomorrow we'll start new chapter. Okay, thank you.